Hey guys, this is quite a good question, this one. This is from exercise 11C, so if I get my little pen working there. We've got Sam and Marcus standing on level ground 100 metres apart. A large tree is due north of Marcus and on a bearing of 65 degrees from Sam. And then the top of the tree is at an angle of 25 degrees to Sam, angle of elevation, and 15 to Marcus. Find the height of the tree. So what I'm going to do first of all is draw a flat ground representation. Now, initially when I drew this, I just had a little go before. I drew it like that and said, you know, here's Marcus and here's Sam. And it says they're on level ground, but it doesn't say that they're actually east-west of each other. So, let's make sure we get our thinking right. And here's Sam. Here's Marcus. Now, the example would have worked out. The answer works out the same either way. But it's important we get it right here. So they're 100 metres apart, not necessarily east-west of each other. But this tree is directly north of Marcus, and it is on an angle of 65 degrees from Sam. Now, then we're given, here we call this, there's the height of the tree. We're given two other bits of information. If I let this equal the height of the tree, I'm going to call this length A and B. Why not? So if I'm drawing side A and then the height of the tree there, H, this must be going from Sam to the base of the tree, which is there, capital T, and then to the top of the tree. And that angle of elevation from Sam is 15 degrees. And we've got another one over here from Marcus where it's 25 degrees. From Marcus to the base of the tree, and then the angle of elevation to the top. That's what the 25 degrees was. So there's an H there. And I've called this one B. Now, in order to figure this out, I can see I can get an equation in H and B here, and an equation in H and A there. So I could express this side in terms of H and that side in terms of H, which when I've got three sides, I'm thinking I can probably solve using the cosine rule, but I'm missing one thing, aren't I? I'm missing the angle in there. So, how do I go about figuring out that angle? Well, if that is on a north line and it continues all the way through there, that north line, then that distance around there must be 180 degrees. And if I continue this bearing from Sam, that's got that being 65 degrees, then you can see this other angle in here is going to be vertically opposite. That's going to be 65 as well. The other way you could do it is you just add 180 degrees and then you've got the 65 there. So either way, you can see that they must be equal. You could also, if you wanted to, put a little 25 in there, have that go across to make a right angle if that was running east-west, and then it has to be 65. So there's a few ways you can get it. But once you've got that 65 degrees, we're now in a position to try and solve. There you go, did want to rub it out. So here I've got, remember, the side that's opposite the angle is on its own. So I've got 100 squared equals A squared plus B squared minus 2AB cosine 65 degrees. Now, we said we needed to replace those expressions for A and B and get them in terms of H. Here I've got the tan of 15 degrees would equal H over A. So multiply by A and divide by tan 15. I get A equals H divided by tan of 15 degrees. Similarly over here, I won't bore you with all the working, but you can see tan of 25 is H over B, swap them around, and B is H over tan 25 degrees. I've now got something I can sub into my equation and solve. So 100 squared, 10,000. This is going to be H squared over tan squared 15 plus H squared over tan squared 25 minus 2 A and B. When I multiply them together, I'm going to have H squared on top over tan 15, tan 25, and I've still got the cosine 65 degrees there. Now it's just a matter of pushing buttons on your calculator to solve. It may be a little bit tricky for you to do that looking at this one. If you want to make it look a lot nicer, you'll of course take all of that and multiply through by the common denominator. So we're multiplied by tan squared 15, tan squared 25. I would get somewhere that would eliminate all of those things, and then I'd be just left with my h squareds, and I'd be able to see how many of them I have and solve it from there. That's one way you could do it. You could also just plug in what is the tan of 15, what's the tan of 25, solve them individually, divide by that, and then figure it out that way. I'll keep going on the path that I've started. I think it's usually easiest if we save our calculator for the end. So this left-hand term will now be 10,000 tan squared 15, tan squared 25, keeping those in brackets so you know they're all being multiplied together. What I've got left here, now I've got tan squared 25 multiplying h squared. The second term, the tan squared 25 is cancelled, but I've got tan squared 15 multiplying h squared. And in the last term there, the tan 15 and tan 25, one each of them cancels, and I've actually got, this is a doozy, isn't it? Negative 2 cos 65, and I've still got one more tan 15 and one more tan 25. All of that is multiplying h squared. Good news is, h squared's a common factor there, isn't it? Let's make a little bit more room here. And now you could actually work out that left-hand side on your calculator, but I'm going to do it all at once. So here we've got 10,000 tan squared 15, tan squared 25. It's h squared. And what was the bits? What were the bits I had left over? This is fantastic, isn't it? Tan squared 25 plus tan squared 15 minus 2 cos 65 tan 15 tan 25. We obviously now do division. 10,000 tan squared 15 tan squared 25 divided by tan squared 25 plus tan squared 15. Doesn't really matter if I do them in the other order. 15 minus 2 cos 65 tan 15 tan 25. And that's h squared. Square root of that will give me h. Let's have some fun. See if we can get our calculator to give us the answer. Have I got the calculator in here somewhere? It's a good question. Do I have it in there somewhere? Yes, there it is. Alright, let's go back so we can actually see what we're doing. Now I'm working in degrees here, so I need to first of all change my setup and make sure I'm working in degrees. Degrees it is. Good. Okay, so now I have 10,000 multiplied by the tan of 15 squared. So even though we write tan squared 15 when we put it in our calculators, we need to do it that way. And the tan of 25 squared. 156 and a bit. Fantastic. Doesn't really mean anything yet. We're going to divide it by that whole expression. Can we see it there? Move it over this way. I'm going to need some brackets here. Whoop. Tan squared 15. So yes, tan of 15 squared plus tan squared 25. Oh, I've got my 25 and 15 backwards again. Doesn't matter. Tan of 25 squared minus 2 cos 65 tan 25 tan 15. Close that bracket. So that answer's been dividing all of it. 850.17. Now of course that is h squared, isn't it? So h squared, we might as well put it all in. Now I can go to my little approximately equal to signs because I'm rounding off a little bit here. 850, and we square root the 850 to get the answer. So I'm just going to go to the power of 0.5 because it's fewer strokes. 29.157 meters. The height of that tree is about 29.1516 meters to the nearest centimeter. There you go. It's a good question. I hope that helps. Keep the questions coming. We need a few more. I think we could all benefit from doing a bit more practice. Catch you in the next video. See you guys.